Welcome to the video solution of your selected question from the Mathematics the Easy Way DVD. If you have not yet seen the introduction video on the DVD, please do so now, as it outlines how the Easy Way series will help students to be successful in their CXC exam. While the Easy Way video solutions will help to cement the understanding of certain special questions, the solution books are still absolutely necessary as they cover all the various types of questions that are set in CXC exams.
We are now at question 8 of the CXC CSET June 2013 General Paper 2 exam video solution. In this question, we are given the first 3 diagrams in a sequence, and each diagram consists of a number of wires and plasticine balls. And in this first diagram, we have 12 wires and 8 balls. The 1 here means diagram 1. So the number of wires in diagram 1 is 12, and the number of balls in diagram 1 is 8. So that's it. We have 12 wires and 8 balls. Now to get diagram 2, this shape is added to diagram 1. And this shape has 8 wires and 4 balls. And then to get diagram 3, this shape is then added to diagram 2, and the trend continues, or the pattern continues like that. Now it is important to observe a pattern formula when doing these types of questions, and to derive the pattern formula we need to observe how the number of wires and the number of balls are added from diagram to diagram. So in the first diagram there are 12 wires and 8 balls, and the second diagram is obtained by adding 8 wires and 4 balls. And so we can come up with a formula for the second diagram. The number of wires in the second diagram, in diagram 2, is 12. 12 from the first diagram plus 8 times 1. 1 is the number of times that this was added. So the result is 20. So it's 12 wires from the first diagram plus 8 wires that was added here. And this 8 wires was added once, hence the 1 here. Total is 20 wires in this diagram. And then the number of balls in the second diagram is equal to 8 balls from the first diagram plus the 4 balls that were added. And the 1 here means that the 4 balls were added once. And so the total number of balls in this second diagram is 12. The formula for the third diagram, or the number of wires and number of balls from the third diagram, can be derived in a similar way. The 12 wires from the first diagram and this diagram was added twice. So 8 wires were added twice to this diagram to get this third diagram, and 4 balls were added twice to this first diagram to get this third diagram. And so the number of wires in the third diagram is 12 plus 8 times 2, that's 28, or we simply add 8 more wires to the 20 here. And then the number of balls in the third diagram is 8 plus 4 times 2, which means 4 balls were added to the 8 balls from this first diagram twice, or simply we add 4 more balls to the 12 balls that were in diagram 2. The result is 16, and so this diagram has 16 balls, and that's the pattern. So if we observe the pattern now, we see that the number here that we are multiplying by the 8 is 1 less than this. Also the number here that we are multiplying by 4 is 1 less than this. Similarly here, the number here 2 is 1 less than the diagram number 3, which is here, and the number 2 here again is 1 less than the diagram number here. So basically we can observe the pattern, and so the number of wires and the number of balls in diagram N would be equal to this formula. Number of wires in diagram N would be 12 plus 8 times n minus 1. The number that we're multiplying 8 by is 1 less than the number here. And so it is 12 plus 8 times n minus 1. And then the number of balls in diagram N would be 8 plus 4 times n minus 1. We are multiplying by 1 less than the diagram number. And so this is our observed pattern that we can use going forward. Alright, now we need to draw the fourth diagram. This is the information we have so far. Alright, and we now need to draw the fourth diagram. So To draw the fourth diagram, we simply bring the third diagram in. That's the third diagram, and we're adding this, the 8 wires and 4 balls, to this third diagram to create the fourth diagram. And that is it. We add that to the third diagram, and that's our resulting fourth diagram. And we can establish the formula again for the number of wires and the number of balls in this fourth diagram, following on the same pattern or using these pattern formulae that we have derived. And this is it. Number of wires in this fourth diagram is 12 plus 8 times 3. 3 is 1 less than 4. Or simply, we could add 8 more wires to this 28 wires in the third diagram. The result is still 36. And then for the number of balls is 8 plus 4 times 3. 3 is 1 less than the 4 here in the fourth diagram. And so the result is 20. Or again, we could do this calculation by simply adding 4 more balls to the number of balls in this third diagram. In any case, the number of wires in the fourth diagram is 36, and the number of balls in the fourth diagram is 20. But what I noticed in this exam is that students had a problem drawing this fourth diagram on the grid that was provided. And so on the next slide, I show how that could have been done. This fourth diagram was to be drawn on a grid presented like this in the exam. And let's go through step by step how we could draw this diagram on this grid. And the first thing to notice is that the distance between the bars would be 2 grid points, and the distance from here to here would be a diagonal between 2 grids. And so we could draw this line up here first, representing this side, and then come across the diagonal here to represent this side, and that's it. And then we could go down, pull a line 2 units down for this side, and that's it. And then we could complete this end square by drawing across the diagonal here, and that's it. And then we recognize now for the fourth diagram there are 2, 4, 6, 8 units across the top. So we need a line that is 8 units across the top here. And that's it. That's 8 units. 1, 2, 3, 4, 5, 6, 7, 8 units. And we also need lines that are 8 units across here from this point, 8 units across here from this point, and 8 units across here from this point. So we can go ahead and show those other lines that are all 8 units. And that's it. 8 units across there, 8 units across there, and 8 units across here. We could also now complete the square at the back of the shape, and that's it. A line up there, a line across here, a line down here, and a line across there. And then all we need to do now is put the balls in 2 units apart along the top. See, the balls are 2 units apart across the top, so we can show that. So these are the balls 2 units apart. Again, on this line the balls are 2 units apart on this line, and that's it. So those are the balls. And then on this line the balls again 2 units apart, so that's it. One here, one here, one here, there and there. And then on this line again the balls are 2 units apart, and that's it. Ball here, ball here, ball here, ball here. And then we need to join these balls to complete this square right here. We need to join these balls with straight lines. And so we draw a line from this up to here, then come across here, then a line down here, and then a line down there, and that's it. We have completed our first diagram. And so to complete this second one, we do the same thing. A line here, a line here, a line down here, and a line across there. That will complete our second diagram. Third diagram completed again by drawing a line here, a line across here, a line down here, and a line across here. And that's it. And our fourth diagram is already complete because we already placed those lines in. And that's how you could draw that diagram in an exam on a grid like that. You can stop and rewind this video to see step by step again how this diagram could be drawn. In any case, that's the fourth diagram, and so let's move down now to part B. Now in part B, we're required to complete this table which shows the diagram number, the number of wires in each diagram, and the number of balls in each diagram. Now in part 1, we need to complete these two cells for the fourth diagram, and we know to go from the third diagram to the fourth diagram, the number of wires is obtained by adding 8 more wires to the number of wires in the third diagram. And so the number of wires in the fourth diagram is obtained by adding 8 to 28, and that is 36. Number of balls in the fourth diagram is obtained by adding 4 to the number of balls in the third diagram, and so 16 plus 4 equals 20, and that's the same figure as we established from the previous slide, where the number of wires in the fourth diagram is 36 and the number of balls in the fourth diagram is 20. Now to calculate the number of wires and the number of balls in the 20th diagram, we can use a formula that we have for the number of wires and the number of balls in the nth diagram. And so here we just need to substitute a value of 20 in these two formulae. And so the number of wires will be equal to 12 plus 8 times 19. That's 20 minus 1 is 19. And so here it will be 12 plus 8 times 20 minus 1 is 19. 12 plus 8 times 19. When we do that calculation, the result is 164. And then for the number of balls, similarly, is 8 plus 4 times 20 minus 1. 20 minus 1 is 19. And so the number of balls here would be 8 plus 4 times 19. 8 plus 4 times 19 is 84. And so there are 84 balls in the 20th diagram. And so that's the answer for that part of that question. Let's move down now to part C. Now in part C, we are required to write expressions for W, the number of wires, and B, the number of balls in the nth diagram. We already have these expressions, but these expressions can be simplified. And so let's show that. We have that the number of wires in the nth diagram would be 12 plus 8 times n minus 1. And if we expand this bracketed term, we end up with the number of wires being equal to 12 plus 8n minus 8. And then 12 minus 8 is 4. And so the result here is that the number of wires will be 8n plus 4. So that's a reduced or a simplified expression for the number of wires in the nth diagram. And we could do a similar thing for the number of balls. Starting with this expression here for the number of balls that we derive from the first section, the number of balls is 8 plus 4 times n minus 1. Again, we can expand this and we end up with number of balls being equal to 8 plus 4n minus 4. And then 8 minus 4 is 4. And so we are left with the number of balls being equal to 4n plus 4. And again, that's a more simplified expression for the number of balls in the nth diagram. B, number of balls in the nth diagram is 4n plus 4. And so that's the answer for that part of this question. And that's the end of this question. So we'll do our next question, question 9, in our next video. See you then.
You have just seen the video solution for a special CXC question, but this is only one of the many different ways that these questions are written. All mathematical principles can only be fully understood by solving many questions, and so I always tell my students, more maths equals better maths, and if they study hard, they will pass easily. All the various types of CXC questions are covered in the Easy Way Mathematics Solution book, and you need to practice every single one of them. Other books in the series are the Easy Way Multiple Choice Specimen book, the Easy Way Unit 1 Cape Mathematics Solution book, and the Easy Way Account Solution book. Please feel free to contact me with your comments and queries at any time.